Yes. Okay, in the last video, we discussed about what does the slope of a curve mean. ಸೊ ಸ್ಲೋಪ್ ಆಫ್ ಎ ಕರ್ವ್ ಅಂದರೆ ಏನು ಅಂತ ಹೇಳಿ ಕಳೆದ ವಿಡಿಯೋದಲ್ಲಿ ನಾವು ಅದರ ಬಗ್ಗೆ ಒಂದು ಮಾಹಿತಿಯನ್ನು ಕೊಟ್ಟಿದ್ದೇವೆ. Now it is time to prove that the slope of velocity time graph will give you the acceleration of the body. So now we need to prove that slope of velocity time graph is the acceleration of the body. Now let me consider a velocity time graph of a body. It starts from west, imagine, and it is moving with uniform acceleration. So let me consider a velocity time graph for a body starting from rest and moving along a straight line with uniform velocity. Consider a graph like this. So this is the nature of the graph. Therefore I write the nature of the graph is as shown in the diagram. Okay. So this is the nature of the graph. So you have many other types of velocity time graphs also. So we have discussed about the nature of velocity time graph when the body is moving along a straight line with uniform velocity. So we have also discussed about the nature of the graph when the velocity of the body changes instantly and so on. But here I have considered the graph of the body which is moving along the straight line with uniform velocity and starting from rest. Let us say that this graph you obtain makes angle theta with the horizontal axis, that is the time axis. Let us say the graph, or you say the curve, makes angle theta with the time axis. Now let me consider 2 points. One point say A, the other point say B on the curve. So there are 2 points which I select. One point is A, the other point is B. A and B are any 2 points. So there are different points. Any 2 points cannot coincide on the velocity time graph. So at A, so let us say the body is at A while moving, it has velocity u, and when the body reaches B, it has velocity v. So I write here, when the body is at a, its velocity is u and at v, its velocity is v. So from u it has changed to v. Now let me draw two perpendicular lines to the horizontal axis from point A and point B. Call these two perpendiculars as P and Q respectively. So I write here AP and BQ are drawn perpendiculars to the time axis. Okay. And from point A, I draw another perpendicular line, say AC, to the line BQ. So BQ AC perpendicular. So also draw AC perpendicular to the line BC. These are my constructions. And you observe the diagram carefully. So diagram when you carefully observe madure, you will find that angle BAC, which is here, angle BAC. This is also theta. So these two angles are equal because AC and this horizontal axis of time are parallel to each other, and AB serves as the transversal corresponding angles. ಕನ್ನಡದಲ್ಲಿ ಅನುರೂಪ ಕೋನಗಳು ಅಂತ ಕರೀತಾರೆ. ಎರಡು ಸಮಾಂತರ ಸರಳ ರೇಖೆಗಳು ಬೇರೆ ಒಂದು ರೇಖೆಯಿಂದ ಛೇದಿಸಲ್ಪಟ್ಟಾಗ ಅನುರೂಪ ಕೋನಗಳು ಸಮವಾಗಿರುತ್ತೆ. The corresponding angles are equal when two parallel lines are cut by transversal, and therefore you can say angle BAC is also theta because they are corresponding angles. Now we see here, what is the length of BC? Length of BC is V, this is V, minus U, this is U. So V minus U will be length of BC. This is V, BQ is V, because you have V here. AP is U, because you have U here. So therefore, BC will be equal to V minus, and then AC will be equal to time that has elapsed when the body displaces from point A to point B. So point A to point B ಗೆ body ಹೋಗಬೇಕಾದ್ರೆ ಎಷ್ಟು ಟೈಮ್ ಇಲ್ಯಾಪ್ಸ್ ಆಯಿತು, ಎಷ್ಟು ಟೈಮ್ ಕಳೀತು ಅನ್ನೋದನ್ನ AC ತೋರಿಸ್ಕೊಡುತ್ತೆ. ಇದು ಟೈಮ್ ಆಕ್ಸಿಸ್ಗೆ ಪ್ಯಾರಲಲ್ ಆಗುತ್ತೆ. And you can say AC is T. So these are my constructions. Now you have a triangle in triangle ABC. ABC is definitely a right angle triangle. You know, ABC is undoubtedly a right angle triangle. So I will define tan theta in that triangle. So theta is the angle here at vertex A. So we all know the definition of tan theta says that It is the ratio of opposite side to angle theta and adjacent side to angle theta. Angle theta opposite side yavudu side BC. Adjacent side yavudu side AC. AC is the side adjacent to angle theta. So now tan theta is slope of the line. So slope of velocity time curve. So we have defined slope. Slope is the tangent of the angle made by the line with the x-axis in the positive direction. So therefore, tan theta will give you the slope of the line or slope of VT graph. So slope of VT curve or VT graph, whatever you call it, no problem, is equal to BC. I substitute for BC, B minus U, and I substitute for AC, which is T. So which is the changing velocity. V is the velocity at point B. A is the velocity of the body at point A. So V minus U will give you the changing velocity of the body. This place is from point A to point B. Point A and point B, the body hodaga is change the velocity. So changing velocity divided by time. You all know change in velocity by time will give you the acceleration of the body. The acceleration kodutte. So therefore, slope of VT graph is the acceleration of the body at that instant. So ನಿಮಗೆ ಇದರಿಂದ ಏನು ಪ್ರೂವ್ ಮಾಡಿದಂಗಾಯಿತು? Slope of velocity time graph gives you the acceleration. So that is what you need to prove, and you proved it. And here you came to know that slope of velocity time graph is acceleration, and this also implies slope of velocity time graph is V minus U by T ಅಂತ ಗೊತ್ತಾಗೋದಿದೆ ನನಗೆ. Slope of velocity time graph is V minus U by T. I substitute here. I represent acceleration by A. I cross multiply T. I get V minus U is equal to AT. I transfer minus U to the right hand side of the equal to symbol. Therefore, I get V is equal to U plus AT. So this is one of the relations between the velocities of the body at different instances, acceleration of the body, and the time interval that has elapsed. This equation will be called as equation of motion, and specifically first equation of motion. There are different equations of motion, and this equation is first equation of motion. So first equation of motion will give you the relation between the velocity of the body at two different instances, its acceleration, and the time that has elapsed to change the velocity. So idu ಬಹಳ ಇಂಪಾರ್ಟೆಂಟ್ ಇಕ್ವೇಷನ್ನು. ಇದನ್ನು ಫಸ್ಟ್ ಈಕ್ವೇಷನ್ ಆಫ್ ಮೋಷನ್ ಅಂತ ಕರೀತಾರೆ. ಅದರ ಡಿರೈವೇಷನ್ ಅದು ಹೇಗೆ ಬಂತು ಅನ್ನೋದನ್ನು ಗ್ರಾಫ್ ಮೂಲಕ ಈ ಥರ ತೋರಿಸ್ಬೇಕು. ಇದರೊಳಗೆ ಎರಡು ಪರ್ಪಸ್ ಸರ್ವ್ ಆಗಿದೆ. ದೇರ್ ಆರ್ ಟೂ ಪರ್ಪಸಸ್ ದಟ್ ಹ್ಯಾಸ್ ಬೀನ್ ಸರ್ವ್ಡ್. ದ ಫಸ್ಟ್ ಈಸ್ ದ್ಯಾಟ್ you prove that slope of velocity time graph is the acceleration of the body, and secondly, you arrived at the relation between the two velocities at two different instances, acceleration of the body and the time that has elapsed. Now we have to prove two more equations of motion. Inno ಎರಡು equation ನಾವು prove ಮಾಡಬೇಕು. So those equations should also be proved with the help of velocity time graph. ಅದಕ್ಕೆ ಬೇರೆ ಮೆಥಡ್ ಇದೆ, ಅನಾಲಿಟಿಕಲ್ ಮೆಥಡ್. ಆದರೆ ಅಕಾರ್ಡಿಂಗ್ ಟು ದ ಸಿಲೆಬಸ್ ಪ್ರಿಸ್ಕ್ರೈಬ್ಡ್, we have to prove those equations with the help of velocity time graph only. ಸೊ ಬೇರೆ ಥರ ಪ್ರೂವ್ ಮಾಡಬಹುದು, ಮಾಡಬಾರ್ದು ಅಂತ ಏನಿಲ್ಲ. ಆದರೆ ಸ್ಪೆಸಿಫಿಕ್ ಆಗಿ ನಮಗೆ ಸಿಲೆಬಸ್ಸಲ್ಲಿ ಪ್ರಿಸ್ಕ್ರೈಬ್ ಮಾಡಿರೋದು ಗ್ರಾಫ್ ಉಪಯೋಗಿಸಿ ಮಾಡಿಕೊಡಿ ಅಂತ. ಸೊ ನಾವು ದ ನೆಕ್ಸ್ಟ್ equation that you need to prove, or you have to prove that area under the velocity time graph between any two instances. ಯಾವುದೋ ವೆಲಾಸಿಟಿ ಟೈಮ್ ಗ್ರಾಫ್ ಆಗಲಿ ಹೇಗಾದರೂ ಹಿಡಿಯೋದು, ಆಗ ಆ ಏರಿಯಾ ಅದರ ಕೆಳಗಿರೋ ಏರಿಯಾ, it will give you the displacement of the body in that particular instance. ಆ ಸಮಯದಲ್ಲಿ ಬಾಡಿ ಎಷ್ಟು ಡಿಸ್ಪ್ಲೇಸ್ ಆಗುತ್ತೆ ಅನ್ನೋದನ್ನು ತೋರಿಸುತ್ತೆ ಅಂತ ಪ್ರೂವ್ ಮಾಡಬೇಕು. ಆದರೆ ನೆನ್ಪಿಟ್ಕೋಬೇಕು ನಾವು, ಆಲ್ ದೀಸ್ ಈಕ್ವೇಷನ್ಸ್ ಆಫ್ ಮೋಷನ್, ವಾಟ್ ಎವರ್ ವಿ ಪ್ರೂವ್, only holds good for a body which is moving along the straight line only. Straight line ಅಲ್ಲಿ ಮಾತ್ರ ಮೂವ್ ಆಗ್ತಾ ಇರೋದು ಒಂದು. ಎರಡನೇದು, you have to remember that those equations of motion are valid only when the body is moving with uniform acceleration. So non-uniform acceleration ಇದ್ದರೆ ಈ ಥರದ ಈಕ್ವೇಷನ್ಸ್ ಎಲ್ಲ ಅದಕ್ಕೆ ಸರಿ ಹೋಗುತ್ತಿಲ್ಲ. ಈಗಾಗಲೇ ಒಂದು ಈಕ್ವೇಷನ್ ನಾವು ಪ್ರೂವ್ ಮಾಡಿದ್ದೀವಿ. ದ ನೆಕ್ಸ್ಟ್ ಈಕ್ವೇಷನ್ ಈಸ್ ಟು ಶೋ ದಟ್ the velocity time graphs, area under velocity time graphs equation, the velocity time graph will give you the displacement of the body in that particular instant. So we shall prove it in the next video that we come across.